Okay, trig and pre-calc. We're talking about graphs of polar equations with this section. As you can see, I already took a take at this video. But what we're going to do is we're going to sketch the graph on this one, and I'm going to let you sketch the graph on here. So what we're going to do when we sketch these graphs is, you can barely see it. Man, I'm really going to have to get like a better camera to record or something. But we have our polar equation here, r equals 4 sine theta. And what we're going to do to graph this is just like what we do with rectangular equations when we choose values for x and find values for y. We're just going to choose values for theta and find values for r. So our chosen values for theta are here. These are ones that are commonly seen on things like the unit circle, and are in intervals of pi over 6, so that we will have basically the entire pattern formed by the time we're done. So if we start at 0, we're going to say r is equal to 4 times the sine of 0. And the sine of 0 is 0 because, remember, sine measures distance up and down, and cosine measures distance left and right, like that. So we're going to have a big fat 0 in this box. Pi over 6 is going to be right here, so it's kind of going to look like this triangle. And so we're going to take the sine of this side right here, opposite over adjacent, and we know that if we plug that into the calculator or just use our trig functions, that this is going to be a ratio of 1/2, and then we're going to multiply that by 4, equals 2, and that's how we're going to get that value right there. And so the next one, we're going to look at pi over 3, and similarly we've got the same triangle, but it's just flipped a little bit, rotated a little bit I should say. And what we're going to do here is we're going to take the sine of pi over 3, and if we look at the sine of pi over 3, we're going to get a total of square root of 3 times x. So sine pi over 3 equals square root of 3, and square root of 3 times 4 is equal to 4 times the square root of 3. And then we can just keep it like that. It got a little messy. Pi over 2, I'm just going to continue on and fill these out because y'all can find these on your calculator. But pi over 2 is going to be right here, so the cosine is going to be 1 times whatever the scalar is. The scalar is 4, so we're just going to have 4. And as I said, I'm just going to continue down the row because I think that y'all can find these with calculators or with trig. -2, -4, -2, 0. Okay, so once we have our points, we're going to go ahead and graph these. And we've already gone over how to plot points on a polar graph, but we'll check out what this pattern starts to look like. So first of all, we got 0, 0 right at the center. Pi over 6, 2, so we're going to go pi over 6 right here, and we're going to go 2 lines out that way. Then we've got pi over 3 and 4 times the square root of 3, and the square root of 3 is about 1.3-ish. So 4 times the square root of 3 is equal to 6.9. And you know, now that I'm doing this, I'm questioning whether this is right, because 4 times the sine of pi over 3 is just equal to not 4 times the square root of 3, but 2 times the square root of 3. So that was my bad. Hopefully that didn't ruin your notes or anything. So we've got 2 times the square root of 3, 4, 2 times the square root of 3, and so on. So when we go back to the graph here, 2 times the square root of 3 ends up being about 3.5. So what we're going to do is look at our angle, pi over 3, go out about 3.5 circles, and put a mark. Next up, we got pi over 2, 4. 1, 2, 3, 4 straight up. Next up we got 2 pi over 3 and 2 times the square root of 3. So 2 pi over 3 is right here, and we already know that we're going to go about 3.5 circles, so 1, 2, 3.5. Next up we got 5 pi over 6 and 2, so we're just going to go here. And then this is where it gets kind of funky. We're going to go to pi, and we're going to go 0. We're going to go a magnitude of 0 that way, and so that's just going to leave us right here. 7 pi over 6 brings us down here, right? And so if we go this way, -2, that means we're really going to go this way, +2. So we're going to look at this line. We're going to see that it extends out this way, and we're going to put our dot right here. And you'll notice that it corresponds to the other point we already had there. Similarly, if we look at 3 pi over 2, it's going to be right here. And if we go -4 downward, that's really going 4 upward. And if we go 4 upward, we meet up with that point. And same thing with this point here, 11 pi over 6. We're going to go the opposite way, 2, and then we've got 2 pi, 0 here. So that's graphing, and when you connect these points, what it's going to look like is a circle. If you were to fill in the points around the dots. So that is how we graph something with polar coordinates. Hopefully it wasn't too confusing for y'all. Go ahead and try this example out. You'll have to find probably the same, or you'll at least need to be able to find a pattern. So starting with theta at 0 and working your way down is probably a good place to start and a good method to use. So go ahead and try that out, and we'll hit you with some more videos in a second.